Good day, everybody. How are you all? Today we are going to talk about how to construct confidence interval for the population mean when the population standard deviation is known. So here I go. Confidence intervals for population mean when the population standard deviation is known. We have described statistical analysis as a four-step process whose steps are we formulate questions. What is the research questions that we want to answer? Collect data required, related or needed to answer the questions. Then we describe the characteristics of the data and we draw conclusions using appropriate methods. We now discuss the construction of confidence intervals, which are one of the most commonly used methods for drawing conclusions. Construct and interpret confidence interval for a population mean when the population standard deviation is known. A simple random sample of 100 fourth graders is selected to take place in a new experimental approach to teaching of reading. At the end of the program, the students will be given a standardized reading test. Suppose that the mean score for the 100 students in a program was X bar, means sample average is 67.30. Now the administrators want to estimate what the mean score would be if the entire population of fourth graders in the district had enrolled in the program. Right now, the best estimate for the population mean is sample mean, X bar, which is 67.30. This is called a point estimate. So it's one value estimate of the population mean. Will it be exactly the population mean? May or may not be. It is very unlikely that X bar is equal to 67.30, that is the sample mean, is exactly equal to the population mean. In order for the estimate to be useful, we must describe how close it is likely to be. For example, if we think that it could be, say, off by 10 points, we would estimate the population mean within the interval 57.30, which is obtained by subtracting 10 from 67.30, which is the sample mean. So the lower boundary of the interval is 57.30, and the upper boundary is obtained by adding 10. Previously it was subtracting, now adding. 67.30 plus 10 is 77.30. This could also be written as 67.30 plus or minus 10. Plus or minus 10 means once we will do the subtraction to get the lower interval, the other time we will add 10 to 67.30 to get the upper boundary of the confidence interval. The plus or minus number is called the margin of error. The interval used to estimate the value of the parameter is called the confidence interval. Okay. So 10 is called the margin of error. Suppose that we require a certain level of confidence, say 95%, that the interval contains the population mean. The real question is, what should be the margin of error be in order to have 95% confidence that the population mean is in the interval? Okay. So as you see, 67.30 sample mean is in the center, and we need to find out the margin of error such that we have 95% confidence in the interval. Okay. The margin of error for any level of confidence can be found using the sampling distribution of X bar, probability distribution of X bar sample mean. We begin by finding the margin of error for 95% confidence interval and then generalizing the method. Recall the previous technique used to find z-scores that bound the central 95% of area under the standard normal curve. So area in the center is 0.95. That means area in two tails is 1 minus 0.95 because the total area under the curve is 1. 1 minus 0.95 is 0.05. That is the area in two tails. But remember, the normal curve is symmetric. That means total area in the tails, which is 0.05, will be divided equally in two parts. One part in the left tail, one part in the right tail. 0.05 divided by 2 is 0.025. So area in the left tail is 0.025. What is the value of Z1? We are dealing with a standard normal curve whose center where the peak is the highest is Z equal to 0. So we need to find Z1 and Z2. Z1, area in the left tail, area to the left of Z1 is 0.025. So we go second, verse 3. Area in the left tail is 0.025. We are dealing with the standard normal curve. Z is 0, mu is 0, sigma is 1. We paste enter and enter. That value of Z1 on the left is minus 1.96. If you are wondering why it is minus, because remember in the center, you see a mark in the center where the peak is the highest, relative frequency is highest, that is Z equal to 0. So on the left of 0, we have negative values. Now, how to find Z2? We'll use the same approach. What is the area to the left of Z2 under the standard normal curve? Is the highlighted area 0.95 plus the area in the left tail 0.025 is 0.975. So we go second, verse, and again 3. Now it is not 0.025, it's 0.025 plus 0.95, which is 0.975 is the area under the standard normal curve to the left of Z2. We do not change anything else. Mu is 0, sigma is 1. Paste, enter, and enter. And that value of Z2 is 1.96. Here there is a typo. Z2 should be positive 1.96. That is 95% of the area under the standard normal curve is bounded within 1.96 standard deviation. The number 1.96 is called the critical value. When sample size is large, n greater than 30, the central limit theorem tells that the sampling distribution of x bar is approximately normal with mean mu, and standard error means the standard deviation of the sampling distribution is sigma x bar. Remember, sigma x bar is sigma of the population divided by square root of the sample size. Because the sampling distribution of x bar is normal, 95% of all sample means will lie within 1.96 standard deviation of the mean. So that is mu minus 1.96 sigma x bar times sigma x bar. Again, that is the standard deviation of the sampling distribution, also called the standard area. That is the lower boundary, and the upper boundary is mu plus 1.96 sigma x bar. That means all the sample means will fall within that. Okay, that's why you have mu minus 1.96 sigma x, lower boundary less than, that means that is the lowest value, x bar less than mu plus 1.96 sigma x bar, which is the right boundary for the for the boundary within which 95% of x bar will fall. But we are basically interested in finding the confidence interval for the population mean, not for the sample mean. So we will subtract x bar from all of them and do algebraic manipulation to show that with 95% confidence, we can state that the actual population mean mu will fall within x bar minus 1.96 sigma x bar that comes from the previous inequality by doing algebra, less than, that is the lower boundary, and that is the lowest value of mu, and the upper boundary is x plus 1.96 sigma x bar. With 95% confidence, we can state that the population mean is contained in x bar plus minus 1.96 sigma x bar. Just to remind you, x bar is a sample mean, 1.96 because we have 95% confidence, times sigma x bar. Sigma x bar is the standard deviation of the sampling distribution. Sigma x bar is equal to sigma population standard deviation divided by square root of the sample size. In other words, the margin of error, remember we had said x bar plus minus E is the margin of error, and that is equal to 1.96 is the critical value times the standard error. For the example of the new approach to reading, suppose that we know from the past results that the scores on the standardized reading test have a population standard deviation of 15. So the standard error is sigma divided by square root of n. 15 divided by square root of 100 is 1.5. That's your standard error, which is the standard deviation of the sampling distribution of X bar. Hence, the margin of error is critical value times standard of error. 95% confidence critical value is 1.96 times the margin of error 1.5 is 2.94. So what is the confidence interval for the population mean? 95% confidence interval is X bar minus 2.94 and X bar plus 2.94. And we plug in the value of X bar, and with 95% confidence, we can state that the actual population mean will fall between 64.36 and 70.24. A point estimate is a single number that is used to estimate the value of an unknown parameter. A confidence interval is an interval that is used to estimate the value of a parameter, means population characteristic. In our case, it is population mean. The confidence level is a percentage between 0% and 100% that measures the success rate of the method used to construct that confidence interval. What is the meaning of that? Meaning is if we collect sample data 100 times and construct 100 confidence intervals using that formula, out of those 100 intervals, 95 intervals will contain the actual population mean. The remaining 5 will not. And my success rate is 95%. That is my confidence level. And what is the margin of error? Is the critical value multiplied by the standard error. Find the critical values for a confidence interval. Although 95% is most commonly used confidence level, sometimes we will want to construct a confidence interval with a different confidence level. We can construct a confidence interval with any confidence level between 0% and 100% by finding the appropriate critical value for that level. Critical values for several confidence levels are given in the bottom row of table A3. So, let's do the critical value for 90%. That means area in the center of the normal distribution is 0.9. What is the area in the two-tail? Is 1 minus 0.9. 1 minus 0.9 is 0.1. That is the area in two tails. Now, because of symmetry in the normal distribution, left tail area is equal to right tail area. So total area of the two tails is 0.1. Area of each tail will be 0.1 divided by 2, which is 0.05. 0.1 divided by 2 is 0.05. Now we need to find out the minus z, the negative critical value. So second verse 3. So second verse 3 in norm. Area in the left tail, remember, is 0.1 divided by 2 is 0.05. And we go down to paste, hit enter, enter twice. And the critical value on the left is minus 1.645. What about the critical value on the right? Remember 0.9 in the center plus the area in the left tail, which is 0.05, is 0.95. So second verse 3, now instead of 0.05, type the area as 0.95, go down to paste, hit enter, and you get the value as 1.645. So the left critical value is minus 1.645. The right critical value is also 1.645 with a positive. It's a positive number. Okay. So they have given us the sample mean. They have given us the standard error. We first need to find out the margin of error, which is the critical value times margin of error. We already found out the critical value for 90% confidence is 1.645. Multiply that by the margin of, by the standard error, which is the standard deviation of the sampling distribution, is 2.3. So 1.645 times 2.3 is 1.645 times 3 is 1.645 times 3 is 1.645. Oh, 1.645 times the margin of error is 2.3 is 3.7835, which they have rounded to 3.8. So the lower boundary for the confidence interval is the sample mean 7.1 minus the margin of error, which is actually it's 3.7835, and that is equal to 3.3165. And what about the upper boundary is sample mean, which is 7.1 plus 3.7835, which is equal to 10.8835. So what can we say? With 90% confidence, we can state that the actual population mean will be between 3.3 and 10.9. Z alpha notation, sometimes we may need to find the critical value for a confidence level not given in table A3. To do this, it's useful to learn a notation for a Z-score with a given area to its right. The Z alpha notation refers to the Z-score with an area of alpha to its right. Okay. The Z alpha by 2 refers to a Z-score with an area of alpha by 2. So area in the center is 1 minus alpha. If 1 minus alpha is the confidence level, then the critical values on the right is Z alpha by 2 and on the left is minus Z alpha by 2. Now, what is 1 minus alpha? Suppose it is 0.95. Then 1 minus alpha, the confidence level. 1 minus alpha is the confidence level is 95%, is 0.95. Then in that case, alpha is 1 minus 0.95 is 0.05, and alpha by 2 is 0.05 divided by 2 is 0.025. Okay. So we are not going to use the table. Here the confidence level is 92. So the area in the two tails is 1 minus 0.92, which is 0.08. That's two tails. Divide that by 2. Area in each tail is 0.04. 0.08 divided by 2 is 0.04. Then second verse 3. Area in each tail is 0.04. And you go down to paste, hit enter and enter. And the critical value is 1.7506. Okay, as shown over here. 0.96. So they want to find Z alpha by 2. Area to the left of it is 0.92 in the center plus 0.04 in the left tail is 0.96. So we go second verse 3. Area is 0.96. Mean is 0.1. Paste, enter and enter. And it's the same value positive, 1.75068. That's how we do it. Okay. The Z interval command constructs a confidence interval for a population mean when the population standard deviation sigma is known. This command is accessed by pressing stat and highlighting the test and then scrolling down to Z interval. Okay, we do not worry about Excel. The problem is sigma is usually not known. Sigma is a population standard deviation. And we will learn how to construct confidence interval in that case in the next section. Assumptions are we have a simple random sample. Either the sample size is large or the sample must have come from a population which is approximately normal. That means bell-shaped probability distribution. So they want us to find the critical value for Z alpha by 2 for a 98% confidence. That means area in the two tails is 0.02, area in each tail is 0.01. To find Z alpha by 2, which is on the right, area in the center is 0.98 plus area in the left tail is 0.01. So total area to the left of Z alpha by 2 is 0.99. So second verse 3, area is 0.99 and paste, enter and enter. And that critical value is 2.326 as you see in the calculator. And find the margin of error for a 99% confidence interval with standard error. Remember, that is the standard deviation of the sampling distribution. First, we have to find the critical value for 99% confidence interval. 0.99 area in the center. Area in each tail is, area in two tails is 1 minus 0.99, which is 0.01. Divide that by 2 to get area in each tail, which is 0.005. So area to the left of this Z alpha by 2 is 0.99 in the center plus 0.005 on the left tail. So second verse 3, Area in the center is 0.99 plus area in the left tail is 0.005. Total area to the left of Z alpha by 2 is 0.995. And we go down to PEST, hit enter and enter. The critical value is 2.576. So take that critical value of 2.576 and multiply it by 0.4, which is the standard error, and the margin of error is 1.03. Okay. So IQ test was given to a simple random sample of 75 students at a certain college. The sample mean score was 105.2. Scores of the test are known to have a standard deviation sigma is 10. Okay, verify that the sample assumptions are satisfied. Now the sample size is 75 is much greater than 30. So we can assume the sample came from a random, from a normal distribution. The population is normally distributed or bell-shaped. Hence the assumptions are satisfied. And the main reason is that because the sample size is much greater than 30. Okay, construct a 90% confidence interval. Let's use the calculator to do this. So we will do stat, highlight test on the top row, then we scroll down to Z interval. The reason we are using Z interval because the population standard deviation sigma equal to 10 is known. So we bring the cursor on 7, which is Z interval, and hit enter. Input is stats. Are not going to enter the data. So input normally is flashing on stats on the first line. That's fine if you know the sample statistics. So sigma in this case is 10. X bar sample mean is 105.2. Sample size N is 75. C level is 90%, so 0.9. And we calculate. So with 90% confidence, we can state that the actual population mean will be between 103.3, 107.1. Okay. Is it likely that the population mean is greater than 100? Yes, because the 95% confidence interval starts from 103.3. Okay. Same idea over here. Sample of 50 battery. 50 battery, if N is 50 greater than 30, so the assumptions are satisfied. Part B is construct a 95% confidence interval. Again, stat, highlight test means move the cursor on the top line to test and scroll down to number 7, which is the Z interval. We are using Z interval because we know the population standard deviation. Okay. Input on stats, sigma is 20. X bar sample mean 120.1. N sample size is 50. C level is 0.95. And we calculate. So with 95% confidence interval, confidence, we can state that the actual population will fall between 114.56 and 125.64. Okay. Is it likely that the population mean is greater than 130? No, because 95% confidence interval starts from 114.56 and ends in 125.64. Okay, so I will stop here today. If you have any question, comment, do drop me a note. I will respond as soon as possible. And if you like this video, please give me a thumbs up. That really motivates me. So please do not forget to give me a thumbs up. If you like this video, share this video with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button in the bottom right corner. And also, please hit on the click on the bell. That will help you to be notified every time I upload a new video. So please do not forget to click on the bell. And again, please subscribe to my channel. I've solved all kinds of math problems just for you. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for taking the time to watch my video. I appreciate that. Thanks and see you tomorrow. Take care. Have a nice day.